Hey everyone, welcome to Linear Algebra. This will be lecture 0 of the course, i.e. the course introduction. And in this video I just want to go through a few little bookkeeping items for the course just to kind of set expectations and get you prepared. So the first thing I want to talk through is textbooks. So for those of you who are not just casually watching or scrolling through YouTube, maybe you want to follow along more closely, and maybe you want to do some practice problems. Here are the textbooks that I recommend and use in the preparation for the course. So the first one, the one that I use most, is called Elementary Linear Algebra. And this is by Andrilli and Hecker. Okay, and so this was a textbook that was big in the 2010s, I would say, maybe 2005-ish, thereabouts. And it's a great book. It's kind of geared more towards your math major, taking linear algebra, meaning that it's a little more geared towards like proof writing and being able to prove the theorems that we come across. So this will be the main book that I use, and so if you're just going to get one, I would recommend this one. If you want some variation in your library, I would also recommend, and I do use, Linear Algebra and Applications. And this book is written by David Lay. And so this particular textbook is a little more geared towards an engineering student, or possibly a science student who's taking linear algebra to support their engineering or science work. So it's a little more geared towards applied linear algebra. Less proof writing and a little more just on applications. Both books are great. You just have to make a choice at the onset, and the choice that I made for the course was to make it a little more proof heavy, and so that's going to naturally lend itself to the first book. And so if you weren't going to get a book to follow along with, I would recommend Elementary Linear Algebra, but I do pull a lot of examples from the David Lay textbook as well. So those are the books that I recommend. Let's talk just really quickly about kind of the setup of the course and how you should think about this. So this is a full semester course. Okay, so it's a full semester course, and what does that mean? Well, on YouTube, you'll run into lots of videos that are just one-off videos, like here's how you calculate the determinant of a 2x2 matrix, or here's how to do matrix multiplication, etc. Those are great little one-offs if you need some specific instruction on something. This course, by contrast, is a full semester course, meaning that like everything that you would cover in a normal undergraduate linear algebra course is covered in this course, right? Meaning there's some lecture material for basically the entire gambit of linear algebra topics that are fair game for a sophomore or junior level undergraduate course. And so I think this is a great this series of lectures works well if you're taking linear algebra. You can tune in here, and if you find the instruction here to be helpful as a supplement, that's kind of the idea here. Also, if you just want to kind of learn mathematics on your own, and you're not in a university, this would be a great course, meaning you're not going to miss anything if you were to go through these lectures end to end, right? You would be basically getting the same material that you would get in an undergraduate course, and especially if you were to buy the book and do the practice problems in the book, you would be in a good spot. So it's a full semester course, and what that amounts to approximately is, something like 25 lectures, and that's going to be anywhere. It's going to be somewhere between, it's going to be approximately 35 hours of lectures. The lectures are anywhere from an hour to 2 hours. It sort of depends on the topic. So that's pretty comparable to what you might expect in a regular course in a university. So that's kind of the extent of the course, and then I'll just briefly touch on the broad sections of the course. So the first section is going to be vectors and matrices. And here we're going to basically discuss how to do arithmetic with kind of the objects of linear algebra. So how do you add two matrices? How do you do matrix multiplication? How do you multiply these things together, etc. So just basically the arithmetic of linear algebra objects. The second broad section is going to be systems of linear equations. Okay, so here's where we'll discuss how to basically solve algebraic systems using matrices and vectors. We'll also introduce things like rank of a matrix, row space, matrix inverses, etc. So some of the key ideas from linear algebra will be kind of brought up in this section as well. Following that, we jump into determinants. This is a really fundamental linear algebra topic. And we get into determinants and eigenvalues in this section. And so this takes a little more of a theoretic turn, but these are still highly useful, and have a lot of applications, but we'll kind of jump into that. Following that, we will look at vector spaces. And so this will be a great section for people who are getting, maybe getting excited about writing proofs and wanting to think about mathematics in more abstract sense, vector spaces. And so here we'll introduce the idea of subspaces and the span of a matrix, et cetera, et cetera. And so lots of very, very cool stuff in vector spaces. And then finally, we'll end on what are called linear transformations. Okay, and so linear transformations are kind of, so that's another fascinating area of linear algebra, which we will sort of end on. And I'm going to say there'll be roughly 4 lectures here, maybe 4 here, 4 to 5 on determinants, maybe more on vector space. I'm going to guess 7, and then maybe another 4 or 5 down here. So that gets us 4, 8, 12, 16. Yeah, that's roughly it. Maybe a few more here and there. So that's kind of an outline of what we're going to cover in the course. And again, these are all the broad areas that you will go through if you're taking linear algebra at a university, right? So these are going to be the same basic layout of as what you would get in a university. So anyways, again, 25-ish lectures, roughly 35 hours to complete. Here are the textbooks you can follow along with and do practice problems out of. Highly recommend the first one, Elementary Linear Algebra, Drewley and Hecker. And so anyways, that's all I wanted to say for the introduction. Best of luck. Hopefully you find these useful. Please let me know if there's anything I can do to improve the lectures. And I will do my best to do so. Okay, that'll be it. The next video we'll jump into vectors and matrices, and we'll just get right into it. So take care, and we'll talk to you all next time.